I'm going to go over the problems from the review page, the math review. That way if you have any questions or you're seeking clarification, you can look at me work out the problem, and hopefully that will help. Problem number 1 is 6n plus 18. And it says to apply the distributive property and write an equivalent expression. What we're going to be doing is factoring. So we're looking for the common factor of 6 and 18. 6 can be divided by 6 and 18 can be divided by 6. Therefore, 6 is the greatest common factor. So we're going to basically pull 6 out of those two factors. And inside these parentheses, we're going to write the remainders. So 6 divided by 6 is 1. 1n is the same as n. I'm going to keep the same operation. 18 divided by 6 is 3. And there you have it, an equivalent expression. To check, we can multiply. So 6 times n is 6n, and 6 times 3 is 18, and we're back to where we started. Number 2 is long. It takes time. There are a lot of steps to complete, but it is not difficult if you break it down and don't let all the numbers and variables overwhelm you. So we have a fourth times 12x minus 3 minus 2/3 x plus 4x plus 11 and a fourth. And the objective is to simplify the expression. Simplifying expressions means to combine like terms. Before we can combine the like terms, though, we need to apply the distributive property to this section right here. This is very similar to what we just did up here. We want to multiply 1/4 times 12x, and then we want to multiply 1/4 times -3. So we need to do that step first. We're multiplying a fraction, no big deal. We multiply fractions by fractions. So we need to take 12 and turn that into a fraction, and we do that by simply adding a 1 in the denominator. And now we can multiply straight across. You can either multiply straight across and then reduce, or you can reduce first by cross-canceling. So 4 goes into 4 one time, and 12 is divided by 4 3 times. Now we have 1 times 3 over 1, which is the same as the whole number 3. Because 12 has an x with it, this is 3x. So instead of 12x, I now have 3x, okay, minus, now I need to multiply 1/4 and 3. So again, I need to change 3 to a fraction by adding a 1 in the denominator. I cannot cross-cancel because, Leia, shh, I'm doing a video. 4 cannot go into 3. So I multiply straight across, and I have 3 over 4. Okay, so now I have 3x minus 3/4. Okay, so I'm done with that part of the expression. I continue writing it. I still have -2/3 x plus 4x plus 11 and 1/4. So looking at this, I have common terms. 3x, 2/3 x, and 4x are all common or like terms because they all have a number with a variable, a coefficient variable. 3/4 and 11 and a fourth are like terms because they are both numbers without variables. Hey, puppies, now is not the time to be playing, okay? Not right now. Shh. So we want to combine, in other words, group the like terms. So I'm going to group 3x. I'm going to pay attention to the sign that comes before the number. 3x minus 2/3 x. I'm going to pay attention to the sign plus puppies, 4x. I've put all of those like terms together. Now I'm going to combine the other like terms. I pay attention to the sign that comes first. Minus 3/4 plus 11 1/4. At this point, I'm just gonna follow order of operations, and I'm just gonna work it out from left to right. One thing I am gonna do over here is I'm going to convert 11 1/4 into a fraction greater than 1. So I'm gonna turn this into 45/4. 11 times 4 is 44 plus 1 is 45. Okay? That way I can add. So 3x minus 2/3 x. Again, when you're subtracting with fractions, you can only subtract a fraction from a fraction. So we need to convert 3x into a fraction by adding a 1. So now we're going to do 3/1 minus 2/3. In order to subtract fractions, hey, Luke and Leia. Sorry. Hey, shh. Shh. Not right now. When you subtract fractions, you need a common denominator. So we're going to find the common denominator, which will be 3. In order to turn 1 into a 3, I'm going to multiply by 3. Whatever I do to the bottom, I need to do to the top. Okay, so now I have 9/3 minus 2/3. The denominator stays the same, and I simply subtract in the numerators. 9 minus 2 is 7. Okay, so this 3x minus 2/3 x is now 7/3x plus 4x minus 3/4 plus 45/4. So now I'm going to add 7/3 plus 4x. Again, when I add fractions, I need to add fractions. So I need to convert 4 into a fraction. So 7/3 plus 4/1. And again, I need a common denominator, which in this case is 3. So I multiply both the denominator and the numerator by 3. And this gives me 7/3 plus 12/3, which equals 19/3x. Okay, so now I have 19/3x minus, okay, so now I need to do 3/4 plus 45/4. But notice that the sign in front is negative, so this is really negative 3/4 plus 45/4. The denominators are already the same, so I don't need to change those. I'm just going to move it on over. This is -3 plus 45. So the way I need to think about that is on the number line. Here I am at 0 and here I am at -3. I need to move a total of 45 steps from -3 to wherever I land. To get from -3 to 0 is a move of 3 steps. 45 minus 3 leaves 42 more steps to go. So this is 42/4. I know that there is a number that can go into both 4 and 42, so I want to reduce. That number is 2. This gives me 21/2. I've added those. I now have 19x minus 21/2. I cannot simplify any further because these two terms are not alike. This has a variable with it, this one does not, so we can't combine any further. That's a long one, it has a lot of steps, but the most important thing to remember is combining those like terms and changing those whole numbers into fractions before you do any kind of operations. Okay, let's take a look at number 3. So number 3, 6 plus 2 plus 5 is something to 5 plus 6 plus 2. And the objective is to compare the expressions. So the first thing to notice is that on both sides, they have the very same addends. They both have a 6, they both have a 2, they both have a 5. That tells me 8 plus 5 is 13, 11 plus 2 is 13. Because these addends are the same, I know that the sums are the same, and because they're the same, I would say that these are equal. Number 4 says that 2.5, oops, that's why we always use pencil in math, 2.5 plus 3 1/4 divided by 5/8. Here, the order of operations needs to be followed, PEMDAS. And according to order of operations, division needs to occur before addition. So this needs to happen before we add 2.5. Okay, so I have a mixed number and I have a fraction. That's okay. I'm simply going to change this mixed number into a fraction also, and then follow the rules for dividing fractions. 12 plus 1, so I have 13 over 4 divided by 5 over 8. Now I divide. Keep, change, and flip. Keep the first fraction, change the operation, and flip the second fraction. Then follow the basic rules of multiplying, which means multiply straight across, cross cancel first if you can. 5 cannot go into 13, but 4 can go into 8. So 4 divided by 4 is 1, and 8 divided by 4 is 2. 13 times 2 is 26 over 5. Now I want to convert this into 5 over 2 plus 26 over 5. When we add fractions, we need to have a common denominator. The common multiple here is 10. To make this 10, I'm going to multiply the top and the bottom by 5. To change 5 to 10, I'm going to multiply by 2, so I'm going to multiply the top by 2. I'm going to rewrite. So this becomes 25 over 10 plus 52 over 10. I keep the denominator and I add the numerators. I have 77 over 10, which is a fraction greater than 1. So I'm going to simplify by turning it into a mixed number. 10 can go into 77 7 times. That's 70. 77 minus 70 leaves a remainder of 7 out of a denominator of 10. And that is the answer. For number 5, we're simplifying an expression again. So we're going to have two different terms. We have 5x plus 2x minus 2x minus 1 plus 6. Okay, so these terms have already been grouped according to their likeness. These are all like terms because they have coefficients and variables. These are like terms because they are both simply numbers with no variables. So we're just going to apply the properties, apply the operations to this set first. 5x plus 2x is 7x minus 2x 7x minus 2x is 5x. We could also notice that 2x minus 2x is 0, so 5x plus 0 is still 5x. Okay, over here, however, pay attention, because the fact that there is a minus sign in front of the 1, it does not mean that you're adding 1 and 6. You're adding negative 1 and 6. So negative 1 plus 6 is 5. You can stop here, or you can go one step further and you can factor this expression. A common factor to 5 and 5 is 5. 5 divided by 5 is 1, or x, plus 5 divided by 5 is 1. Either one of these are acceptable answers because they are equivalent. This is just taking it a step further and factoring it. Okay, number 6. Number 6. 15 plus 25 is the expression, and we want to factor the expression. We're dealing with the distributive property, so we want to find the greatest common factor. 15 and 25. 5 can go into both of these. So think of it as we're pulling 5 out of these two factors. We're going to pull it out, and we're going to be left with remainders inside. 15 divided by 5 is 3. And keeping the operation, 25 divided by 5 is 5. Okay, so when we apply distributive property here to check, what we're saying is that 5 times 3 plus 5 times 5 is 15 plus 25, and that checks out. So this is correct. Number 7. Evaluate 10x plus 3y, x equals 4, y equals 2. Remember, a variable is an unknown. Any value can be put in its place. So when we don't have a numerical value, we put a variable instead. Here we're given values for those variables. So instead of keeping the variables, we're going to substitute. So instead of 10x, it's 10 times 4, plus, instead of 3 times y, it's 3 times 2. And then we solve. 10 times 4 is 40, plus 3 times 2 is 6, which equals 46. Number 8. Okay, again, same thing. You have x over 24 plus 3. And we're told that x equals 6. So we're going to substitute. Instead of x, it's going to be 6 over 24 plus 3. This is a division problem. This is 6 divided by 4 plus 3. And there's a few ways to get to your answer. You can first just divide 6 by 24. Because you're dividing a smaller number by a greater number, you'll have a number less than 1. I can't put 24 into 6, so I'm going to add a decimal and a 0. I'm going to raise my decimal. I said I cannot put 24 into 6, so that's a 0. 24 can go into 60. 2 can go into 6 3 times. 20 times 3 is 60. Therefore, I know that 24 times 3 is too much. So I know I want to do 2. 2 times 24 is 48. I'm left with 12. 24 can't go into 12, but I can add another 0 here, bring it down. 24 goes into 120. Now I know that 2 goes into 12 6 times. I know that 20 times 6 would be 120. Therefore, 24 times 6 will be greater than 120. Therefore, I know that the factor I'm looking for is 5. 5 times 24 equals 120. Okay, so 6 divided by 24 is 0.25. Another way to get to that answer is to look at this as a fraction and reduce it first. 6 divided by 6 equals 1, and 24 divided by 6 equals 4. 1 over 4 is the same as a quarter, or 0.25. So now we have 0.25 plus 3, which equals 3.25. For number 9, y divided by 20 equals 20. What is the value of y? So sometimes when you're working with problems that deal with numbers in the 20s and above, sometimes it's easier to stop and imagine this problem being done with small numbers that you can easily work with. So imagine if you had a division problem such as x divided by 5 equals 2. Well, you know that 10 divided by 5 equals 2. And you can check that because if you multiply 5 times 2, you end up at 10. 10 divided by 5 equals 2 because 2 times 5 equals 10. Again, if you are doing a division problem, you can use its opposite, multiplication, to find the quotient. If you were doing multiplication, you could use the opposite, division, to find its product. So in this case, when you're looking for y and it's a division problem, you can multiply. 20 times 20 is 400. And it's true that 400 divided by 20 equals 20. Therefore, y equals 400. Let's take a look at number 10. Number 10. This is a unit rate question. What is the unit rate? So we're going back to ratios. So this is a ratio 10 to 5. When we're looking for a unit rate, we're looking for a ratio that has a 1, typically in the denominator. So 5 divided by 5 is going to give us 1. 10 divided by 5, because whatever you do in the bottom, you do in the top, is going to give us 2. So the unit rate is 2 to 1. Okay. Number 11, apply the distributive property. You have a half times 4x plus 2/4. So when we say distributive property, that means we're going to distribute or pass out this half to both of these terms. So again, when you have a number next to parentheses, that implies multiplication. So what we're saying is we're going to take 1/2, and first we're going to multiply it times 4x. Okay, making note of the operation. Then we're going to add 1/2 times 2/4. We'll solve for these and we'll add them together to get our answer, our sum. So we're going to multiply 1/2 times 4. Again, just because it's a fraction, don't be scared. You have to multiply fractions by fractions. So just change 4 into a fraction. Okay, and multiply straight across. You can cross cancel first. 2 goes into 2 one time. And 4 divided by 2 is 2. 2 over 1 is the same as 2. So 4x times 1/2 is 2x. Plus, now we're going to multiply these two numbers. 1/2 times 2 over 4. You just multiply straight across. You can cross cancel first. This is 1, 1. 1 over 4. 1/2 times 2/4 is 1/4. Okay. We would not continue. You can't add 2x and 1/4 because remember, these are unlike terms, so they cannot be combined. So we would stop right here. If you have any questions about any of these problems, please feel free to contact me, reach out to me. We're also going to go over all of these one more time tomorrow morning.